All right, folks, we're back. And what we're going to do is we're going to take the first derivative rule of finding the derivatives. And it's a common rule called the power rule. And my biggest pet peeves, and again, I have my son Ben here with me.
Hello.
And my biggest pet peeve, in fact, I hope that you've noticed this as I've been teaching you math, is I hate it. I can't stand it when you have equations that you don't really know where they come from. You just know, okay, just use it just because. You know what I mean? Like I've taught you the quadratic equation before, and I've really done you a disservice because I haven't taught you how we get the quadratic equation. Rather, you when you've been reading your book, you said, oh, okay, this is the quadratic equation. I'm just going to use it. And that really, those kinds of things really irk me. And so what I'm going to try to do is I'm going to show you how to do this power rule and where it comes from, and hopefully motivate you as far as like, okay, this is, I can really dig as far as why we use this power rule, and that way you can kind of get an understanding of where it comes from. That way it's not magic that I'm just pulling out of my hat and saying, memorize this from now on. In fact, I think what I'm doing with you, Ben, is I'm almost doing you a disservice, because the way I usually like to teach this to people is I usually make them do like 50 of these problems, and eventually they figure it out themselves, like the slow way. And so what I'm doing right now is I'm kind of like, before you get to struggle with it, I'm almost like the magician who's pulling the curtain back and saying, here's the trick behind it. You know what I mean? Whereas it would be better for you if you just did 100 of these problems and you actually figured it out. Okay. But I'm going to record this video on the power rule anyway, because I think it's really important. So what we're going to do is we're going to find the derivative of some common functions, like f of x equals x squared, or x cubed, or x to the fourth power, or even x to the 97th power. Cool? Okay. So let's do this. Let's write down what is the definition of a derivative. Okay. If I want to find f prime of x, and let's say, all right, so part A, this is when f of x equals x squared. Cool? All right, what I'm going to do first is I'm going to write down the definition, and it's f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Are we cool? Mm-hmm. All right. Let's start filling things in. I'm going to find the limit as h goes to 0 of f of x plus h minus, what is f of x?
F of x is, it's the...
I literally have it written right in front of you. F of x is equal to, this, we're doing part A, when f of x equals
x plus 2, x squared.
X squared. So if I asked you, well, what is f of x? You would say
X squared.
That makes perfect sense, doesn't it? Mm-hmm. All right, x squared. Cool?
Wait. So if x is x squared, if f of x is x squared,
okay,
then wouldn't this be x to the third power?
No. What this would do is, all right, what you're asking about is if I plug in something different into, like, okay, if f of x is equal to x squared, what is f of k?
K squared?
Perfect. What is f of happy face?
Happy face squared?
Exactly. What is f of x plus h.
Then it will be f of x plus h squared.
No, it would. There you don't have the f in there. Like
Oh,
f of k is k squared. F of happy face is happy face squared. Why you said f of x plus h is f of x plus h squared? Then no.
It's just x plus h squared.
X plus h. X plus h
Parentheses squared.
parentheses squared. That makes a big difference. Cool. All right. By the way, what is x plus h squared? That's x squared plus h squared, right? No, dude, I've told you this many, many times. This is not a calculus thing. That's an algebra 1 thing. In fact, I even named this mistake. I told you you would make this mistake, and I called it the boot to the head. So later on, you're going to get a boot in your head. All right, I'm not an abusive parent, by the way. It's just a figure of speech. Okay. Do you know what it is? X squared plus 2xh plus h squared. Right?
Yeah.
And how do you do that? You
factor it.
No, it's not
Well,
factoring.
not factoring.
It's
So you
foil.
just Foil. Yeah.
You foil it. Very good. Cool. So, again, filling in the rest of this thing, I'm taking the limit as h goes to 0 of f of x plus h. We already know that is x squared plus 2xh plus h squared. Cool? That's the f of x plus h. We have to tack on that minus x squared, and where does that come from?
Minus x squared comes from like the
From right here, from minus f of x, and divide that whole thing by h. Okay. So, what do you notice in the numerator? What can we do so far?
You can cancel out the two x's.
Good.
The
X
two
squared
x squared.
plus x squared and minus x squared, they die. Cool? Now, can I simplify this any? Well, here, let me ask you this. If I let h go to 0, is that a problem right now?
No.
I told you there was one rule back when we were talking about domains that was an important one, and that is
X cannot equal to 0.
you mean the denominator.
Yeah, I mean that. Yeah.
The denominator cannot equal to 0, and the problem that we see here is if you let h go to 0 and h is your denominator, then essentially your denominator is going to 0. That's a big problem. Can we simplify this before we evaluate?
You can factor out an h
Okay, why can we factor out an h?
because there's an h squared and h.
Okay, all right, cool. So what you're saying is, since there's an h in every term up on top, I can pull at least one of them out. And then that one h on top will cancel out with that one h on the bottom. Is that what you're saying? Okay, so what you're saying is this becomes the limit as h goes to 0 of 2x. Why don't I write the h?
Because you factored it out.
Because it got canceled. Plus regular h. Why don't I write h squared?
Because you took the h out.
Okay. Can I take this limit? Sure.
Yeah.
What's the limit as h goes to 0? Well,
2x.
just let it go to 0. The limit as h goes to 0 is equal to, sorry, 2x. That's your answer. Are we cool? That wasn't that hard.
Yeah.
I think the hardest part was actually this.
Oh yeah.
Because you know that you're going to get a boot to the face. All right, anyway. So we did part A. We did, if f of x is equal to x squared, we're good. Cool. Let's try the next one. Part B. When f of x is equal to x cubed. Okay. So I want to find the limit as h goes to 0 of f of x plus h minus f of x all divided by h. Now, let's start plugging things in. This is the limit as h goes to 0 of x plus h. Well, okay, well, first of all, what is f of x?
It's x squared. I mean, not squared, cubed.
X cubed, good. And the h is on the bottom. What is x plus h? What is f of x plus h?
It's x. It's x cubed.
What's x plus h cubed? That's what it is, right?
Mm-hmm.
The hard part is, what is x plus h cubed? Okay, that's x cubed plus h cubed, right?
No.
Oh, good. You learned your lesson. No, it's not. What you have to do is it's x plus h times x plus h times x plus h. I'll tell you what it is, just because I'm so smart. It's x cubed plus 3x squared h plus 3xh squared plus h cubed. That's what it is.
Okay.
Are you wondering, how does he know how to do this so quick?
Because you're a math teacher.
Because you're a math. Well, yes, I am a math teacher, and yes, I do this so quick. But wait, what happened? Yeah, there. All right. But it's because I learned about this thing called Pascal's triangle, and I'll show you what it is in just a second. Actually, you know what? Yeah, why don't I show it to you next? Cool. Okay, so one of the things that I know is that let's plug this into here, and so I have the limit as h goes to 0 of x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed all divided by h. Can we simplify this a little bit?
Yeah, you can take out the two x cubes.
Okay, we can do that. Good. All right, what else can we do?
Looks like you can take an h out of everyone.
I can take an h out of every single thing. So let me see. This would be 3x squared plus 3x times h plus h squared. Do you agree? Okay, because I'm warning you, sometimes I deliberately make mistakes just to see if you're paying attention. And in this case, I didn't. But anyway. Are we allowed to let h go to 0? Is there any problems at all with h going to 0?
No.
No, you're absolutely right. There is no problems at all with h going to 0. There would be a problem if there was an h in the denominator, but we've gotten rid of that h in the denominator. And what does this thing become if h goes to 0?
It just becomes 3x squared.
Right, because 3x times 0 is 0, and also 0 squared is also 0. So this is equal to 3x squared. We cool? All right. Part C. When f of x equals x to the 4th power. Now, we want to find the limit as h goes to 0 of f of x plus h minus f of x all divided by h. Now, you should have been paying attention, so let me ask you, what are we starting to write? This is the limit. Come on, do some talking.
It's x plus h parentheses 4, right?
Okay, to the 4th power, good.
And then minus x to the 4th power.
Good. All divided by
Over
h. Perfect. And I'll tell you what f of x plus h to the 4th power is. It is x4 plus, what was it? Oh yeah, 4x cubed h plus 6 x squared h squared plus 4 x x to the first power. Okay, wait. X h cubed plus h to the fourth power. That is what x plus h to the fourth power is. It's giant. Then I have the minus x to the fourth power. Where does that come from?
That comes from the over here.
Okay, the f of x, good. And then we have the h. All right. The limit as h goes to 0. Can I simplify anything?
Yeah.
Okay, what can I simplify?
You can take out these.
Okay, you can cancel those.
And I'm pretty sure you can take an h out of everything.
There's an h inside everything. So this is 4x cubed plus 6x squared h plus 4x h squared plus, you know what, I'm just going to put yada yada yada. Why am I going to put yada yada yada?
Because it doesn't really matter.
Why does it not really matter?
Because they're all going to cancel out.
Oh, I see. So what you're telling me is when I let h go to 0, all of this stuff doesn't matter. Because it will either have a times 0 or times 0 squared or times 0 cubed or 0 to the fourth power or whatever, and all of it doesn't matter. The only thing that's left over is going to be what?
Just the 4x squared. I mean cubed.
4x cubed. There we go. Now, as a side note, do you want to know how I'm doing x plus h to the fourth power in my head? Okay. I will tell you. I'm going to show you this thing called Pascal's triangle. It's really cool, and I wish I could show it to you in greater detail. In fact, I will one day. Let's say a plus b to the first power. Well, that's equal to a plus b. Cool? A plus b to the second power is a squared plus 2ab plus b squared. A plus b cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. And if you don't believe me, in fact, I actually will probably make you do this, is multiply it out. Literally write a plus b times a plus b times a plus b. You FOIL the first one, and then you FOIL in the third one. All right. A plus b to the fourth power is equal to a4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth power. I'll tell you what a plus b to the fifth power is.
I think I'm seeing a pattern.
Okay, it's a5 plus 5a4b plus 10 a cubed b squared plus 10a squared b cubed plus 5a4, I'm sorry, a b to the fourth power plus a b to the fifth power. It's horrible, but I mean, all right. What pattern are you seeing? I'm just curious.
So the first one is always going to be a whatever.
A to the whatever power.
Yeah.
All right, I can dig that.
And then the second one is going to be, I guess the exponent.
Okay, whatever the exponent was.
Yeah, and then a, and then
A to the what?
whatever power minus 1 or something.
Oh, okay. All right. Whatever power minus 1. I like that. I actually like that a lot. In fact, before I even show you the trick to the Pascal's triangle, let me ask you this. Part D, we wanted to find out what is x to the 97th power. That is going to be... So before I show you Pascal's triangle, and I'll come back to that, let's kind of go along with your logic. Part D, when f of x is equal to x to the 97th power, we're going to find the limit as h goes to 0 of f of... Do you know how to... Have you memorized the equation yet?
Yeah.
Okay.
It's
Divided by...
of x plus h, and then f minus f of x.
Yeah, there it is.
Over a.
Okay, good. All right. Now, I know... All right, this is going to be x plus h to the 97th power. Now, you can either do x plus h times x plus h times x plus h 97 times. Or we can... Oh, okay, all right. What is minus f of x? What is that going to give me?
It's just going to give you...
Minus
x plus... I mean, not x plus. X to the 97th power.
Okay.
Over h.
All right, good. Now, we know, according to your thing, that x to the 97th power is going to have a x to the 97th power there, right? Mm-hmm. And then you said it's going to have a plus, and then what?
And that plus 97.
97. X to the
96 power?
96th power, h. Plus, I don't know, question mark, but I do know
that it's going to have both?
That it's going to have x to the 95th power, h squared. Plus, I don't know, x to the 94th power, h cubed. Plus, and I'm going to say dot, 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 h to the 97th power. There's a whole bunch of numbers inside here that I'm going to say I don't really care about.
Yeah.
All right. I'm going to slap on a big minus x to the 97th power. That comes from here. Okay. Divide all that by h. Now, can I simplify this?
Yes.
Okay. This and that get killed. Nothing new. We're cool. All right. Can I simplify this more before I take my limit as h goes to 0?
Yes, you can take out an h.
I can take out an h. Now, this h gets killed by that h. We cool? And this thing over here, all the h's go down by 1 power. So over here I have something times h, and over here I have something times h squared, and so over here I have h to the 96th power. But why doesn't any of these matter to me?
Because they're all gonna die pretty much.
And how are they going to die?
Because h equals 0.
Because h equals 0. So my answer is going to be 97 x to the 96th power. Have you figured out the power rule? What if I said, all right, well, we're going to try E. This is a bonus round. When f of x is equal to x to the 87th power. Actually, I already did something 7. How's about let's go 158th power. What is f prime of x?
Oh, it's gonna be e plus. I mean, not e plus, but e to the 158th power.
E.
I mean, x to the.
No.
What is that?
No. Oh, f prime of x. That's what we've been doing this whole time.
D.
It's the ddx of f of x. Yeah. What is that going to equal to? Here, let me kind of recap what we did. If f of x is equal to x squared, then f prime of x was 2x to the first power. If f of x is equal to x cubed, then f prime of x is equal to 3x to the second power. We also did x to the fourth power. Then f prime of x is equal to 4x cubed. If you don't believe me, just look up on top, because literally there's the 4x cubed, there's the 3x to the second power. All I'm doing is I'm just recapping. So over here, this is f of x is equal to x to the 97th power, and we found that f prime of x is equal to 97 x to the 96th power. Now I'm asking you, well, if f of x is equal to x to the 158th power, then f prime of x is equal to.
It's gonna be
You're gonna write. No, here. Just tell me.
158.
158
X.
x
To the 187th, or not 87th, but 57th.
157. Perfect. Now let's do this. Let's actually make up our power rule. If f of x is equal to x to the nth power, then f prime of x is equal to.
Oh, then f prime of x is equal to the
Whatever n is.
n
times
n minus 1.
X to the n minus 1.
Oh.
This is called the power rule. And if you don't believe me, let me just show you. There it is right here. F d dx of x to the n is equal to n times x to the n minus 1. That is where it comes from. It is not magic. It actually makes sense. Pretty cool.
Yeah, because pretty much you don't have to go through all that factoring.
Exactly. We don't have to do that. We have a trick. But my pet peeve is I hate showing people tricks without actually showing them where it comes from. So now you've been motivated to say, oh, this is where it comes from. Now I can use this trick. And I understand and I feel good about where it comes from. Now, by the way, let me show you how I actually was doing all of these things in my head, because I didn't memorize it and I don't have, paper in front of me to like as my cheat sheet. This is just this is just on the side note. This is an algebra trick. Okay. If I don't write a number over here, what does that imply? It's a.
Oh, it's just.
It's a 1.
Nothing. Just a 1.
No, it's not nothing. Nothing is a 0.
Yeah.
It's a 1, right? So, do you see the pattern with the letters? This goes a squared, and then the next one is a to the 1 less power, and then the next one after that is actually a to the 1 even less power. A to the 0th power is the number 1, by the way.
Yeah.
And over here, this is b to the 0th power, and here's b to the 1st power, and here's b to the 2nd power. Look, a5, a4, a3, a2, a1, a0, b0, b1, b2, b3, b4, b5. Do you see that?
Yeah.
So you're able to figure out the letters for sure. Now, where am I getting these numbers? That's a good question. But let me show you. I'm just going to write down just the numbers. 1 and a 1. 1, 2, 1. In fact, read them off to me. 1.
1, 2.
No, right here.
Oh, 1, 3. 3.
Good.
1.
Good.
1, 4, 6, 4, 1.
Perfect.
And then 1, 5, 10, 10, 5, 1.
Okay. Do you see a pattern amongst these numbers? I'm going to put a 1 up on top here, just to make it look pretty.
Yeah.
What?
I guess it's sort of like. So, starts at 1 and then it goes to 5. And
Okay.
Then it goes to
All right.
10.
So what's the next one? Can we guess it? It would be a 1.
Probably, yeah, a 1.
1, 6.
Yeah. And
All right.
then
We know
another
it's
6.
going to be a 6 over there because it's symmetric.
And then a 12, and then another. Or not a 12.
Nope, not 12.
Would be.
I'll draw in for time's sake. I'm going to draw in some lines and see if it makes any more sense. I'm actually just putting in some V's. And I'm waiting for you to say, "Oh, look at that." It almost looks like a Christmas tree. All right.
Yeah, like a pine cone.
All right, so what is the next number? What goes right here?
A 20?
Nope.
Oh, no, it's 20. A 50?
50?
Oh, no, wait. It's not timesing. It's adding. So a 15? And then a 20? And then a 15?
Yep.
And then...
So if I wanted to write down a plus b to the 6th power, I would go a6 plus a5b plus a4b squared plus a cubed b cubed plus a squared b4 plus ab5 plus b to the 6th power. And what numbers would I put in there? I would put a 1, 6, 15, 20, 15, 6, and a 1. This is called Pascal's triangle. Named after a great mathematician and one of my personal favorites, Blaise Pascal. He wrote a lot of great books.
That's cool.
That is super cool. All right, I hope you enjoyed this edition of Math with Dad and Ben.